all I have to do is touch that, right?
Yes.
Okay.
Should we get? Well, let's get that ready to go.
That's fine. That's
there you
fine.
go. You just touched that.
Okay. Last time I was here, I was listening to a discussion about inhabitants on the rings of Saturn. You might have remembered a fellow was talking about some of the ancient beliefs, inhabitants of the sun.
Oh, yes.
Do you remember?
We were across the hall.
That's right. Really fascinating. In any case, my talk, I'm really just going to talk personally about how I feel about amateur astronomy, why I got into it, and the kind of things that really interest me about it. This quote, I wish I'd found it myself. Actually, I wish I'd written it, but Claudius Ptolemy was an astronomer from about 1 AD, and this probably sums up for me why I got into astronomy. Not to fill my cup with ambrosia, but or be in the presence of Zeus, but the very thought of looking at heavenly bodies like this, to see something of such a magnitude, of such awe-inspiring splendor, just turned me on right away. The first time I saw this quote was actually Neil deGrasse Tyson used it, and it's held up fairly well. I just think that probably more than anything else, it sums up why many of us got into astronomy. This is me. This is what I do daily. You might think we all work during the nighttime, but most of my observations are in the daytime. It's great. I can see things, you know. I don't have to go out to an observatory. It's right in my backyard. And I take a daily sun count of sunspots. I trace them. I go to various sites to identify them. I use different filters to see what's happening on the sun. So that's one of the things I enjoy doing. You might have recalled something about the transit of Venus. It occurred in June. What year, Paul? This was a big day for Paul. In any case, it was the sun was setting in the west, and there's a remarkable sight. You get to see Venus actually crossing the disk of the sun. It was an amazing thing. Now, I've seen airplanes cross the disk of the sun, but to see Venus cross was just an incredible sight. My wife and I set up telescopes inside the garage. It was facing the west anyway. And as Paul does too, we invited people that are walking down the street, hey, come over and take a look at the transit of Venus. And you might think, now I think this gets down to the core of why amateur astronomy is interesting. Okay, you got a dot crossing a yellow disk. Big deal. But think about it. That's a planet crossing the humongous sun. It's a rare event. And when you see it happen, it seems so simple, but in many ways, you're just kind of transfixed by it. We had trouble with people just kind of hogging the telescope, you know, almost saying, well, I think you've had enough, and move them on. Attitudes are different. Other people, no thanks. And I thought, my God, you got a chance to look at something like this, and you don't want to see it. So it's a personal thing. Some people, it doesn't do anything for them. Paul's going to go into this more detail. I do my nighttime observing at the Calumet Astronomy Center. It's, if you're familiar with, what's the farm, Paul? The Buckley Homestead. It's just south of the Buckley Homestead. It's a nice site. Mainly what I use for this is this pad. We have an observatory here. This is for astrophotography. I don't use any of that. This is my area right here. I just set up my scope, and I'm on this concrete apron. And for a long time, I was by myself. And, you know, I'm retired, so I can go during the weeks. Wonderful. And I needed a companion. And my wife showed some interest in this. But the way I really hooked her on astronomy, she loves maps. And she came out one night with us, and she's looking there. And I said, you know, if you look at this star atlas, this is just a map. And lo and behold, she says, well, yeah, that's interesting. And she started finding things. And before I knew it, you know, I had a permanent companion. We go out together. And I think that's what really hooked her on this, is just to find objects. And that's part of the fun of astronomy. You might have heard about technology and go-to telescopes and things like that. I don't like to do that. I like to find things myself. So this is where we do most of our observing. Am I not cooperating with you here?
You're fine.
Okay. Okay, this is how the show begins for us. We usually set up during the daytime. It's kind of hard to get your scopes and all the gear, and I have a lot of gear, all set up at night. So we usually set up during the daytime. This is one of my favorite times. I equate it with the theater darkening before a play. And this is the twilight. It's Venus above there. And it's funny. It is like, to me, a curtain that's about ready to show you the sky. And I just think this is a magical time. You first see the bright stars coming out, planets first, and then before you know it, you look up and the whole sky is right above you. All of a sudden, stars are everywhere. It's just a wonderful experience. There's other reasons why I got into astronomy, and I'll tell you right now, I love the folklore of astronomy. I love the stories that are associated with it. And let's face it, if you were a shepherd 3,000 years ago, there wasn't a lot of entertainment. And so people came up with these stories about the sky. One of my favorites is this one about Andromeda. When we see our participants here, here's the queen of Ethiopia, Cassiopeia. She had bragged that she was more beautiful than the river nymphs. Now, if you know anything about mythology, you know that's not something you do. You never equate yourself to the gods. But she was, I guess, a good-looking woman, and she thought highly of herself, and she said, well, I'm better looking than the river nymphs. Well, what they did was they decided, well, this can't be. They went to their head god, who happened to be, in this case, Poseidon. He's god of the sea, right? Says, you know, she's doing this. This is terrible. And Poseidon says, well, as punishment, I'm going to send this terrible sea monster, Cetus, who's going to ravage your country, just tear it up. Well, the husband of Cassiopeia, Cepheus, being a good king and actually having to do jobs as a king once in a while, said, well, is there any way out of this? Please, Neptune or Poseidon, you know. He says, well, I'll tell you what I'll do. If you sacrifice your daughter Andromeda, then we'll call it even. Well, I mean, he's a king, you know. It's his whole country or one girl. A lot of daughters back then, so he says, okay, I'm going to sacrifice her. Anyway, this is a long story, but I love this stuff. Here comes our great hero, Perseus, and he spots this woman, this beautiful woman chained to a rock. This monster is about ready to eat her up, and he's flying in on the horse Pegasus, and of course he rescued. He'd just come back, by the way, of destroying the Medusa. Remember the snakehead thing? So, I mean, he had some weapons to use. But in any case, all of this shows up in the sky. Here's the queen, Cassiopeia, right here. Here's her husband, Cepheus. Over here, we have the horse Pegasus and the great square of Pegasus. And here we have Andromeda. And finally, it's not coming up yet, but here's the monster Cetus, also called Cetus the whale, but back then it was just referred to as kind of a sea monster. So all these stars have stories about them. And to me, that's fascinating. There are other stories about other constellations. Every one of them, there's myths about. And I just find it interesting when you look at the sky, you're seeing a tapestry of, you know, events, of narratives that have been put out, and people have been seeing for thousands of years. I think that's interesting anyway. Another one, you might be familiar with this, is M45. This is the Pleiades star cluster. Now, here's something that I always thought was interesting. Across all cultures, this is always referred to as the seven sisters or the seven maidens. It was true in China. It was true in India. It was true with the Greeks and the Romans. I don't know why, but they all saw them as seven women. I guess because the cluster itself is so pretty, we naturally associate it with women. But the story of these, now this is a little bit risque, but we'll go with it. Here are the seven sisters. Now, in the Greek myths, of course, there's seven beautiful women cavorting around someplace, and they're being chased by these lustful gods or mortals. It doesn't matter, it depends on the story. And the gods take pity on them, make them into the cluster, the Pleiades. But a better story comes from the Lakota Indians, who also saw, this is not working. Come on, there. The Lakota Indians also saw seven ladies. But they were, I don't know if they were princesses, what they were, but anyway, here they are running around through the woods, having a great time. Girls just want to have fun, you know, that sort of thing. In comes these terrible bears, these humongous bears, starts chasing these girls. And so, according to the Lakota Indians, they sought refuge at the top of this mountain. Now, you should be familiar You've seen this before. You guys have seen Close Encounters of the Third Kind. This is Devil's Tower. So according, they jump up there, and these bears are clawing, trying to reach them, and that's why this particular formation has that. And the Great Spirit cast them into the stars to rescue them. There's a lot of stories about this, but anyway. Another thing I like about astronomy is I like big numbers, and I like scale. And I don't think you get bigger numbers than this. I taught school for, come on, baby, for a long time. And one of the things I taught was 4th grade, and I also had to teach math, which turned out to be a problem. But in any case, we always got into this thing about place value and big numbers. And to me, these numbers here aren't really numbers. These are just words. And my students never really appreciated what that number means. So here's the example I gave. By the way, these numbers are so big. Notice that we've got 6 zeros. This is scientific notation for it. I mean, the scientists can't deal with numbers like that. They have to use special notation. But here's what I told the kids. I always thought this was fascinating. Imagine, just for the sake of argument, that if I stacked flat $10 bills, and for the sake of argument, let's say that if I stacked it 6 feet high, that would be $1 million. Okay? So I've got 6 feet of bills, $1 million. So what is a billion? Well, that's 1,000 times that. So that would be 6,000 feet high. In other words, you'd have to have $1 billion, you'd need over a mile stacked high of $10 bills. Now to go to trillion, you would have 1,000 miles of $10 bills. And these are the kind of numbers we're dealing with in astronomy. This is what I find interesting. Let's take a look at this. This is the Andromeda Galaxy. It's 2.5 million light years away. So let's do the numbers. Light travels 186,000 miles per second. Multiply that by 60 to get light minutes. By 60 again to get light hour. By 24 to get light day. By 365 to get light day or light year. By 2.5 million to get the distance to Andromeda. These are staggering numbers, and to look at this and to think of those distances, I don't know, I always thought it was fascinating. You need a firm touch on this thing. Come on, you can do it. Well, I'm striking out here. Well, it's probably going to do it again. Okay, I don't know about other astronomers, but some of the things I like to observe. Come on. No. How about that one? No, that's no good. That one? Oh, I'm going backwards now. Oh, don't you love technology? It's so wonderful.
Try the plus sign. That might do it.
No, that doesn't do it either.
No, manual.
Yeah, this is not the computer I'm used to
No, we're not.
using, but so you're not getting it here.
Yeah, there we go. Okay.
Do you want me to stand here? And
No, I can do it.
okay.
I was hitting the wrong thing. Here's another thing we like to observe. This is a galactic cluster. Back to M45, the Pleiades again. This is a collection of stars within our own galaxy. This is the Orion Nebula. Too bad it's a bad night, because we could have seen it tonight very easily. It's starting to set in the west, but it's a familiar object. Something I want to mention, though, when you see these beautiful colors and this nice pictures like this is not what I see in a telescope. Very dim objects don't show you color. And when I see the Orion Nebula, I don't see anything like that. What I see is kind of a vaporous, a cloud with 4 stars in the middle. And if I look for a long time, I see quite a bit more, but I see nothing like this. So the question comes, well, why don't you just look at pictures? And the answer is because, I want to see it myself, for real. And when I look at it, I'm not looking at somebody's picture. I'm not looking at somebody's monitor. I'm actually seeing it with my own telescope, with my own eyes. And there's something really about that connects you, I think, more with these things. One thing that does show up better in a telescope than in any pictures is the moon. I mean, the moon is fantastic in a telescope. If you go high power, you can go cruising through the craters and that. It's really quite a ride. Saturn shows up nicely too. Not quite like this, but you can easily see features on Saturn. You can see this is called Cassini's division right here. That's many times visible. We see moons of Saturn as well. Jupiter shows up nicely. This is a transit of a shadow of the moon right here. You can see the Galilean moons as well. A red spot over here. Sometimes Saturn is rotating, sometimes the red spot's visible, sometimes it's not. As I mentioned earlier, I like to do a lot of solar observations, and once again, it's pretty staggering when you think about what the sun, the processes involved, the amount of energy produced, the fact that it's 4.57 billion years ago and it's still going, and there's a lot of activity on the sun as well. This is the Crab Nebula. This was a star that went nova. This is the remnants of it. Occurred about 1,000 years ago, I think. This is also remnants of a nova. This is part of the Veil Nebula. Yes, you can see this in a telescope too. It's, once again, you're not going to see these colors, but you will see the kind of a glow of the remains of a star there. It's the Ring Nebula. Once again, this is a remnant of a star. This is sometimes called a planetary nebula as well. This star right here in the middle is puffed off its layer. This is a pretty easy object to see. This is the iconic vision, the pillars of creation. No, it doesn't look anything like that in a telescope, but yes, you can make out many of the details. It's always so disappointing for people when they come to observe with us, public, you know, they really expect these objects to look like these pictures, and they don't. But once you realize what you're seeing, I think then you appreciate it more. So to finish up here, what can you do to enjoy the night sky? Well, this thing here is a planisphere. You can turn it around depending on what the time is. So I would buy a planisphere, 10 bucks I think maybe. Most important thing is go to a dark site. You don't have to go out to Conway Observatory. Any place out in the country away from city lights is good. And you can use your planisphere and start getting familiar with the sky. Probably the best way to get into this is really not to use any optical aid at all. It's just starting to become familiar with the constellations. Once you learn the constellations in a particular season, then all you have to do is look east, and the new ones start to come up, and you pick them up much easier that way. And finally, scanning the sky with binoculars. Binoculars are the greatest tool you can possibly use. You see a lot of area of the sky, and many of the objects that we look at can be seen in binoculars as well. So it's I have a passion for this. I enjoy doing it, but it's something that I think most people would enjoy. It's free. It's up in the sky. You're seeing it firsthand. There's nobody to interfere with it, and I think it gives you tremendous satisfaction. Thank you.
We'll hear next from Paul Christman, and then at the end we'll have time for questions. You can ask either of each other questions.
I'm Paul Christman, who most of you know as Paulie, and I'd like to help you discover your universe, and talk a little about the world of public astronomy, and I hope I'm half as good as what Richard was. So I've been doing public astronomy basically since 2009. I got with the Chicago astronomers, and then I actually found our local group, Calumet Astronomical Society, a year later, and I hang out with both of these groups quite often. Why astronomy? And Richard covered a lot of it, and around here there's two kinds of observing. There are mosquitoes and bitterly cold. Neither one is fun. But I find it quite thrilling to watch the Earth rotate, basically, as the stars come up and they set, and watch some of the dynamics of our solar system. This was actually December 2011 This is a partial eclipse that was just beginning as the moon was setting. And this is right next to us at Conway Observatory. That's Purdue Calumet's research telescope. And I don't know, I'll never see that again, probably. Not that shot. But yeah, the transit of Venus, I'm glad Richard talked about this a little bit. In 2004, I was not all that interested in astronomy. I had been as a kid, but I knew that this was a rare event, Venus crossing the sun. It happens twice a century. And I went down to Adler Planetarium, and I did not know Joe at the time, but this is my friend Joe Guzman. He was doing a public observation, and I wish I had met him that day, because I only saw Venus as a tiny little dot with a pair of eclipse glasses that I bought for a few dollars. But seeing that dot in front of the sun, I knew I had to see the second one in 2012. They happen in 8-year spans, and then those 8 years are separated by over a century. I had to see the second one. So that was running in the back of my mind for a while. Then in 2007, here at the Porter County Fair, I happened to be at a concert and was watching this really, really bright star across the sky as I'm listening to the music. And I just knew it had to be Jupiter. It was too bright to be a star. It was too far in the middle of the sky to be Venus. So a few weeks later, I went out with a tiny little telescope that I'd bought quite a few years before at Hobby Lobby. And I looked and I saw something that looked like this. Jupiter was just a bright dot. I could see no detail, but you see these dots around it, and I knew they were the Galilean moons, and I was hooked. I started watching the sky naked eye for almost a year. And then in 2008, I finally bought my telescope that I use now, which I brought here. 2008, I also was taking some classes at Purdue North Central, most of them here at the Valpo campus. And I had 2 really good astronomy introductory classes. And I'd been watching the sky. Didn't have a telescope yet for the first semester, and then in the fall, my professor let me bring my telescope for our class observation, and that was the first time that I had had an audience at my telescope showing them the things that I've seen, and I found out I really enjoy letting people see what I've seen, and I don't know, it's still my favorite part. I enjoy observing with other astronomers, and I enjoy observing on my own, but it's when I get to share and talk to people that I get the most passionate about, I think. So, I'm glad, Richard, that you went into a little more detail on some of this, but especially the deep sky. We can see the sun, the moon, the planets, star clusters, double stars, nebula, and galaxies. The sun. I don't observe it as much as Richard does, and not as nearly as often as I should, but I do enjoy seeing the sun, and there are a couple of safe methods. This is actually a projection method. I have just a small little telescope that I bought cheap secondhand for the purpose of observing the sun. If I burn it up, I don't care. So I can shoot the light straight out onto basically a white sheet of cardboard, or this is actually a little safer. It was just a funnel that I cut and put the eyepiece in, and you have no concentrated sunlight exposed, so nobody can accidentally look and burn their eyeballs. So, but then there's also safe solar filters. I actually bought the film online, and then this is just a coffee can lid and some poster board, and it works. So these are sunspots. magnetic activity on the sun that has cooled the surface a little bit. So it appears darker, and the sun rotates in 25 days. So you actually can watch these evolve and sort of rotate for a couple of weeks across the front of the sun. And that can be very interesting if you're keeping track every day or every other day. Luna, our moon. This is my favorite object to enjoy. Yeah, just look at that. And that's not nearly as good as what you see at the eyepiece. She's out almost every night at some point. There's about 3 days around new moon where you can't see it, but if you're willing to get up early or stay up late, you can probably see it at some point most nights. So we have the near side because the moon orbits the Earth in the same time that it rotates, so we see just one side of it, which is the near side. Oops. I forgot I had to go through all this. I stole this slide from the Lunar and Planetary Society. So yeah, there is no dark side. There's a near side and a far side. And this is the far side of our moon. And I don't know if you've noticed, this is obviously taken from space. Only astronauts and spacecraft in orbit around the moon would be able to see this. But the side facing us is actually a little more interesting, I think. So we got lucky. Key to observing the moon is learn the phases. You start after new moon with the waxing crescent, and it's low in the west, and every night it's a little farther at sunset across the sky. It rises about an hour later every day until you get through to full. At full moon, it's opposite the sun. So as the sun is setting, the moon is coming up, and it then comes up later and later every night until it's rising as a waning crescent just before sunrise. So to see the lunar sunset, you have to either stay up really, really late or get up early. I think I'd rather stay up late. And this is the reason for our lunar phases. The sun is way off that way, and as it comes around, this side is lit, and we see it as a crescent. Does this make sense? Okay. The terminator is what we call this line where the day and night, this is actually sunrise along this line right here. The low sun angle creates deep shadowing, and the shadows give definition to the moon. As you can see, as you get farther away from that line, you don't have those nice shadows, and it kind of starts to look a little washed out. These craters over here are every bit as deep as these over here, but they don't have that shadowing. They're in direct sunlight. It looks washed out. So near the terminator is the best place to observe. Planets. These are fun to watch. Obviously, planet in the ancient Greek meant wander. They actually wander through the sky in relation to the stars. So, summer of 2012, Venus and Jupiter were coming up before the sun, and I happened to catch them with the waning crescent moon. And Jupiter kept going this way over the course of the summer. Venus was coming up earlier and earlier until it got about so high, and then it started dropping back down. And to watch them come up together and then put some distance between them was really fun. So Jupiter, it's a really bad picture, but I took it, so I don't owe anybody any money to use it in my PowerPoint. What to observe on Jupiter, I like to watch as I showed you before, those four little dots, those moons that are about the same size as our moon, over the course of an hour or a day or two, you see them actually move around Jupiter. And if you really pay attention, you can figure out which one is which based just on their motion, which is really, really fun. So to watch the motion of the Galilean moons, these cloud bands, through a telescope, this is a really bad picture. But you get detail in these cloud bands, and Jupiter rotates in 10 hours. So once it gets to the middle here, you've only got about 2 hours, and you can watch, like this is the Great Red Spot. You can watch that cross as Jupiter's rotating. Transits and shadow transits of the Galilean moons. This is when the moons cross in front of Jupiter, and those are really interesting to watch, especially the shadow transits, because you see a little black dot on the planet. So to illustrate, can you see these little dots? No? Okay.
Two, non-water.
Does that help? Can you see the two dots? Okay. This was a night that I observed in 2008. Jupiter was a day or two from being at its nearest point to us for the year. And at 10:22 p.m., Io was right here. And then it crossed in front of Jupiter, and 3 hours later was out on the other side. Ganymede, over the same time, had crossed behind Jupiter and came out over here. So 3 hours, that's quite a bit of motion. And I find that to watch it in real time is just, wow, things move. So this was the same night. Here's Io's shadow. Can you see that okay? When the planets cross in front, they're much harder to see, but those shadows show up nice and dark, and you're watching a solar eclipse on another planet, and that just blows my mind. So Saturn, it gets all the attention at the star parties because of its pretty rings. I don't find it to have to be as interesting as Jupiter, but there are some really cool things. You have the separation of the banding, which is Cassini's division. The ring tilt changes from year to year as we see Saturn at different angles. It shows atmospheric banding like Jupiter does, but it's a lot more subtle. It actually has more visible moons than Jupiter, although only one is bright. The others are pretty faint. You have to look for them, but it has about 8 moons that are visible in telescopes just a little bit bigger than this here. And to me, this is really cool. I don't know if you can see this really well, but that little black spot between Saturn and the rings is Saturn's shadow falling on the backside of the rings, and I saw that. And I don't know, to see, I've barely seen the Earth's shadow, yet I can see a shadow of another planet. Fascinating. Mars, it's so interesting, but it's so small, and this would have been a great night to observe it. You only get about a few months every 2 years because it happens to come close to us in its orbit, and then it gets far away and it gets just to be a little dot that you can't see any surface detail on. But this again was a picture that I took compared to a Hubble shot. The ice caps are usually visible, and I believe that's this little white spot. You're basically only going to see some color differences, which we call albedo. You can see some light and dark here. And when I took this picture, I kind of noticed a little bit of a white haze at the top and the bottom, and north is probably looking to your right. So it would translate to right here. And I was curious and I looked it up. You can actually see clouds on Mars. And I think that's what those little white hazes are at the top and bottom here. And I know that's what it is here. So I see clouds on another planet. Venus, all we see is clouds, but it's really, really bright. It's incredibly bright. I saw it a few mornings ago for the first time in quite a while. I don't know why I was up so early, but anyway. And I had forgotten just how bright Venus is. And you look at it and you go, no way is that a star. And you're right. But it's not a UFO as it often gets mistaken for. But Venus goes through phases. We say like the moon, but it's really not like the moon because it's for different reasons. It's orbiting the sun, but we do see it, and this is another picture of mine as a crescent. This was June 2012. And it was actually getting fatter, getting towards half right at that point. But all we see on Venus is clouds, so basically you're watching that phase. And Mercury, same thing. There's no real detail to be seen because it's small, it's never very high in the sky. So you look for the phase, and because it's always seen in twilight, naked eye observing is actually pretty difficult. Just to see it with the naked eye is usually quite a challenge, and just to see it and know that you're looking at the innermost planet of our solar system is just kind of cool. And there it is again, the summer of 2012, just before sunrise. I don't even know if you could see it if I turn up the light, but it's very, very dim. When I saw, in June of 2012, I saw all of the major planets and Pluto in one night, and Mercury was the planet that I had the most doubt about, even more than Pluto, as far and as small and as faint as it is, because we only had a half hour to find it. But I found it and I saw all the planets one night. Deep sky. The outer planets, comets, asteroids are usually considered solar system objects, but for this presentation I'm going to count them as deep sky because they aren't as visually interesting. And star clusters, nebulae, double stars, galaxies, all that. The fun for me is just finding them, as Richard said, that Phyllis enjoys. It's the finding them a lot of times and knowing that you're seeing this light that has been traveling for hundreds, thousands, possibly even millions of light years, and it's satisfying to find something that's listed on your star chart and say, ooh, wow. So you want to get a telescope and want to know what you should get. Start with binoculars for a couple of reasons. You probably already have some at home, just not being used, and they tend to be fairly cheap. You can see a lot of deep sky objects with them. You'll pick up stars of the Milky Way. You can see some of Jupiter's moons. Our moon looks wonderful in binoculars. But if you want to take the plunge and go for a telescope, go for good quality optics. You don't, that's the most important thing. And then your aperture, which is the size of your mirror or your lens. This right here happens to be 6 inches. Your focal length also will determine how much you can magnify, and don't fall for the high magnification on the box of a telescope because you can only magnify so much without going blurry. And for this particular telescope, if I go over 120 times, I'm starting on all but the best nights, it starts to go blurry. So don't fall for 500 times, you won't see it. Light pollution. That's what our country looks like. We are lighting up the night sky. Can you see this low? The street lights? Yeah. If they're not fully shielded, you're throwing money and light up into our universe and blocking out the universe. So think about changing your lighting. So seriously, you'll save money and you'll allow everybody to enjoy the night sky. That said, I enjoy going out and observing in public, where there are lots of lights, because there also happen to be a lot of people. This was, I think, last year at Adler Planetarium before it got dark, and we were actually seeing Venus. It was so bright it could be seen in the daytime. You can come out to Conway Observatory. We actually have a open house tomorrow night, and we have some flyers up here. Take one before you leave. We will not let you control the telescope. This is actually one of our members trying to find Venus, I think. But yeah, you can look through this monster telescope, or our members will have their telescope set up. We also have the Girl Scouts and other groups come, and this is one of the Girl Scout outings. They do activities during the day. I think here they were learning about cratering, like on the moon, and then once it gets dark, we observe. Those of you who are in Valpo might have seen me over the last few years at Central Park Plaza. I hang out there and I talk to a lot of interesting people and get to show them the moon and the bright planets. And it's a really, really fun time. If you ever see me out there, stop, see what I'm looking at. Columbia College in Chicago, which was another fun night. And you can see all the lights in the background, but this was my first professional experience. They invited me and my friend Joe to give an observation base that tied into an art exhibit they were running. And again, we got to talk to a lot of interesting people just on Michigan Avenue. Happened to run across us and see the moon and Jupiter and its moons. And I was compensated very nicely. So, U.S. Steel Yard. Pollution is a bad thing. Being at a place where people can see you and your telescope is a good thing. So the Railcats were nice enough in 2010 and 2011 to let me and one of our other members bring telescopes out and let people see our moon and Saturn, which was right above their ballpark lights, and people just could not believe that they were seeing another planet that close to those bright lights. I can't believe I found it. But yeah, when you show people what's out there and they can see it through this intense lighting that it takes to play a professional baseball game, I think they start to wonder, what can you see from a darker sight? And to me, that's important. And as a fringe benefit, you get a home run ball, which is now autographed by several members of the 2013 American Association Gary South Shore Railcats. And if you're really, really lucky, if the White Sox have an astronomy event at their camp out night, you might be on their short list to set up your telescope in front of their dugout. And even though it turned out to be cloudy this night, it was one of my favorite experiences ever, just for the photo op. But we did get a few glimpses of the moon. That too. That was the second time I was in the White Sox dugout. So I mentioned the transit of Venus earlier, and that they happen twice a century, and that it was the reason that I got into astronomy. So yes, on June 5th, 2012, I was with many of our other members and Katie, Jade, Steve. We all observed Venus crossing in front of the sun again, and that won't happen again for over a century. I think it's 103 years now. So I'll never see that again. And the smile on my face in that picture just says it all. Thank you, Katie. So why join Calumet Astronomical Society? Well, you can learn from experienced members like me, or Richard, or Phyllis, or Steve. You'd have access to our dark observing site, our telescopes, our binoculars, other equipment, our private message board online, and monthly meetings, which are on the fourth Monday. These are actually open to the public, but the fourth Monday of every month, we meet at Lake Central High School at 7 p.m. So if you'd like to learn a little more about astronomy, and coming up very soon, Dr. Bruce Ribnack will be giving our presentation for us at our meeting, and we appreciate that. So our public observing schedule, we actually have some flyers up here, so I can go through this pretty quick. We have 7 more dates at Conway Observatory. What? Oh, yes, Conway Observatory is handicap accessible. We have ramps. I believe it was the first ADA compliant observatory in the nation. But also we have, if Lowell is too far for you to drive, we'll be at the Indiana Dunes State Park on June 21st and Stevens Park in Cherville on Tuesday, July 15th. So I actually saw this a couple days ago in Valpo. My motto is look up, you never know what you're gonna see. Yeah, it doesn't take a PhD in physics. It doesn't take a multi-$1,000 telescope to be an astronomer. You just need to have some curiosity and look up.
I asked Paul to leave some time that he might have questions for Paul or for Richard. And we've got a telescope along, so before we leave, you can come and see what that looks like and how that works. Questions?
Mary Beth?
What makes Venus so bright? What is it about Venus that makes it so bright?
It reflects 96%, something like 95, 96% of the sunlight that it receives. It reflects that right back out into space.
Well, you mentioned also
its clouds are very reflective.
The cloud,
and it's relatively close to us. If it was farther away, it'd be much dimmer. Light spreads out over distance. So it happens to be relatively close, and being so reflective, it's just amazingly bright.
So the clouds that come
yeah, and it has an insane greenhouse effect. So just imagine if it hadn't, what the temperature on Venus, it's like 900 Fahrenheit. If it didn't reflect so much sunlight, it would really be unbearable.
I might also mention it's the most common object for UFO
Yes.
sightings. If it's low in the sky, they always get UFO sightings about Venus.
Your passion for this is shared by some of us here. My son and I come here a lot. We've seen you all around.
Yep.
Do you ever feel, and I think it's perfect that you showed Devil's Tower, because there are times when I'm talking to people that aren't necessarily as passionate about it. You ever seen the movie, right? I feel like I'm making...
A long time ago.
I feel like I'm making the mashed potato Devil's Tower a lot. You know, you're trying to explain it to other people, you're like, this is fascinating. You just shouldn't need to come out. And is it more important to you to know, just to see these objects, or to like when you see them, when I see that moon, the picture of the moon, I'm thinking of the heavy bombardment period where all that was created and the forces and what that must have been like. not, it's interesting to see the moon, it's very cool, but which is it more important to you just to view it or to understand, or is it a mixture of the two?
I think a mixture of the two. When people see all those craters and they go, wow, this thing must have got beat up. And they start to ask questions like that. Why is there so many craters? Well, that was going on a lot. The Earth probably got hit more, but we've got plate tectonics and weather that erased that over time.
Do you think that most people will, if you can have enough time with them to get to that, or is it more, like we've seen you at the Central Park, where people may be with you for 10 or 15 minutes or so. Do you feel like you get to many people?
Yeah. Probably about 10 to 15%, like really get into it. And the rest, they take a quick, curious look, and for me, even that is enough that maybe I started the wheel spinning in their head, getting them to think, you know, what else is out there? Joey.
I was told that you actually brought them a measure before the county to try and put like hoods on the street lamps or something to reduce the light pollution. How did that ever go through?
Porter County a few years ago passed a resolution. It has no teeth. That county-controlled property, they promised to try to reduce light pollution. I don't know if they're following through with that or not, but I guess it's better than having absolutely no resolution.
St. John did have a restriction on it, but I think it was rescinded, if I'm not mistaken.
I believe it was.
Yeah.
What I know here, I talked to the city engineer, and some of the new lights, if you notice, the new roundabout on Vale Park, those are shielded lights, but the ones that they put up near our observatory, very attractive. You know, you can see well when you're walking, but they just way too many lights. And they said that it would cost money to retrofit them, so maybe they can get swap them out somewhere. So that's what we're at.
Do you try to, you know, the original Copernicus and all those were amateur astronomers as well. Do you make an effort to try to read their stories and what they went through? Or does that help?
I've read a lot of history. I haven't read their original works. I think that's probably above my level. But yeah, I like to know the history. I just naturally like history, and to know the history of astronomy is just a bonus. I think that's why the transit of Venus was so important to me. I knew historically they were important because they were our first attempt to measure the solar system. Mm-hmm. It was a way to triangulate the distance to the sun. And yeah, knowing that history made it a little more special.
Richard, feel free to chime in.
Well, one of the problems is most of them are written in Latin, and we're kind of rusty on that.
Oh, yeah.
So, but there's a lot of history about this, and to see something that Galileo saw, I mean, that you're kind of reliving the history of his observations, and some people are interested in that. They like to do it. Paul was talking about the Galilean moons and tracing. It's exactly what Galileo did. That's how he showed that there were some bodies that were revolving around planets, and it was a contradiction to what the Earth-centered universe theory was at the time. So, yeah, that's interesting to do. By the way, and Paul touched on this business about observing the sun. Astronomy is a very benign interest, but the one really thing that can get you in trouble is solar observation. This is truly dangerous stuff. There used to be a little, Paul, you might remember this, they used to sell cheap telescopes with little a filter, they called it a solar filter. And it was the most dangerous thing in the world because the thing would instantly crack. You'd get this concentrated sunlight in your eyes, and guys would go blind. I mean, when you do solar observation, you really have to be careful about that. I have an optometrist that lives next to me. He had to pull up and say, "Do you know what you're doing out there? You know, you're all going to go blind." But it's one of the things you do have to watch out for.
Anybody else?
I've got about 400, so if you don't mind, I can.
Oh,
we can talk
I've got all
after
night.
that.
We can go
We'll do it
outside.
one at a time.
Oh, yeah. Do you take part in, the Zooniverse, where the variable stars and stuff like that? Is that, or are you more out observing instead of being in front of a computer screen?
I find that to be a very noble endeavor. I just haven't participated in it.
Yeah.
I do like to be out observing.
It is, yeah.
Yeah,
I was
for
wondering if
the
someone in Andromeda watching the
I-
sunlight go dark dim, and they think that there's an exoplanet. And
I kind of wonder the same thing. I wonder if there's somebody looking back from 2,000 or 2 million light year, 2 million years ago, looking back at me, or 2 million years from now looking back at me. And yeah, wave.
There's a lot of grunt work that amateur astronomers do too, that professional astronomers just really can't be bothered with because there's so much of it. One of them is variable stars. Stars don't generally shine with the same amount of light all the time. They vary in their intensity. And there's so many of them that there's a group called the American Association of Variable Star Observers, and they chart the variations in star magnitudes. And that information is used by professional astronomers. Once again, there's so much of it to do that astronomers don't want to bother with it, but they rely on the data from amateurs. There's other groups, just other kinds of observation that they rely on as well. So we do have a useful purpose once in a while.
Maybe one or two more questions, and then you'll be free to go on.
Yeah. What's the best kind of binoculars to get in order to for night viewing?
Just a regular like 10 by 50.
10 by 50.
Yeah, I think that's a good starting point. It's a decent size. If you go too big, they start to get heavy. If you go too much, I have a pair of 16 by 50s. I think that's a little too much magnification because they're hard to hold steady, so they bounce around. The more you magnify, the smaller field of view you're looking at. So, and that bouncing around a little is more noticeable. I think
Even with a tripod?
I don't have a tripod for them yet. That might be something I need to invest in soon.
All right, I got another question.
Okay.
On that one picture about the seven sisters of Pleiades,
Yeah.
what is the distance of those stars between them, and how are they situated? How far are they from Earth? And how are they situated among them?
All of those stars were created at one time. They're all relatively close to each other. I doubt that there are much of a light year separation among those stars, maybe a few light years. I think, Paul, maybe correct me, but I thought the distance to the Pleiades was around 400 light years, something like that. But they're all relatively close. The relative is obviously a catchy term.
Has the size been measured?
Sure. Since they all were born together in the same kind of molecular cloud, they're all about the same distance from the Earth.
But they're not from just one. I mean, was it just one that's
No. What happened is you have a huge cloud. It's a cloud of hydrogen. Actually, it's molecular hydrogen. It starts bunching up, and those little bunches, not little, eventually coalesce into a star. So if one cloud doesn't form one star, I mean, there'd be clump, 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 and each of those would form part of a star in the Pleiades. It's a relatively young cluster. I think it's only maybe 1 million years old, which it's kind of mind-boggling. If you went back 1 million years, you wouldn't see this cluster. Those stars had not been born yet.
Has the size been measured, like the diameter or whatever?
I don't know about the diameter of them. I guess, they infer that because of the type of stars they are. They can tell, they use a spectroscope to see what they're composed of, what type they are, and if they can identify type, most stars in that group or that type would conform to the same size, the same luminosity, so they could infer that. But the stars themselves, stars are never born individually. Almost inevitably they're born in clusters. Even our star was once part of a cluster, but these stars are going this way and that way, and it's hard to tell what original cluster the sun was part of. But it wasn't born by itself. But that's kind of interesting to me too.
One more question over there?
Yeah. Do you get as excited about Aurora as you do other stuff? And do you ever see like a good one around here? I mean, you can.
I honestly don't know.
I've
I've seen the Aurora once, and I was pretty surprised by it, and I was pretty excited. But yeah, I think knowing that we're not likely to see them often around here, I think I would still get just as excited. And overnight on April 14th and 15th, I mentioned a lunar eclipse that I had seen a few years ago. That was the last total lunar eclipse. If you get up about 1 a.m. on April 15th, we have our next total lunar eclipse. And grab schedules for our events and also for VU's events here.
Thank you very much. What we'd like to do, you're welcome to stay. I think both gentlemen will be glad to stay around and talk informally, answer questions. We do have Ryan in the back who's going to open the planetarium, and he's going to head over. How many would like to attend the planetarium program? Okay, so this might be a good time for you to head over with Ryan, and he'll take you over and get that started.